In this video we're going to be working through a A-level exam question which involves a proof and a definite integral. Part A says show that tan x to the 4 is identical to sec squared x tan squared x plus 1 minus sec squared x. So we can see that we've got lots of sec squareds and tan squareds, and the equation that links tan and sec together is 1 plus tan squared x equals sec squared x. I'm going to be using that in just a minute. But the first thing I'm going to do is I'm going to start with the left-hand side. And I'm going to split tan to the 4x up into tan squared x times tan squared x. And I'm going to use this formula here to minus 1 from both sides and say that tan squared x is the same as sec squared x minus 1. So what I'm going to do is I'm going to substitute tan squared x as sec squared minus 1 into this equation. So that's sec squared minus 1. And I'm only going to do that for one of the tan squareds. And now what I'm going to do is multiply out the brackets. So I'm going to get sec squared x tan squared x minus tan squared x. Now, if we look here, we want a tan squared x sec squared x, and we've got that here. The thing that we don't want is the negative tan squared x. We want that to be 1 minus sec squared x. So we're going to replace the tan squared x by sec squared x minus 1 into this here. So that's then identical to sec squared x tan squared x minus all of sec squared x minus 1. Then when we distribute the negative, we get sec squared x tan squared x plus 1 minus sec squared x, and that is the right hand side. Part B says hence find the exact value of the integral between 0 and pi and 4 of tan to the 4x with respect to x. So we know that we can replace this tan to the 4x and it becomes the integral between 0 and pi and 4 of sec squared x tan squared x plus 1 minus sec squared x, and we want to do that with respect to x. Now what I'm going to do is I'm going to integrate this expression here. Now if we look here, we've got sec squared x times tan squared x. Now what I'm going to do is I'm going to use substitution and I'm going to let u equal tan x, because remember, sec squared x tan squared x is the same as sec x all squared times tan x all squared. So we can let u equal what's in the bracket here. So if u equals tan x, u squared will equal tan squared x. And if we differentiate u, du on dx, when you differentiate tan, you get sec squared x. So what I'm going to do is I'm going to split this up and just do the sec squared x tan squared x integral on its own. So what I'm going to do then is multiply by du to get sec squared x dx here, and now I'm going to substitute everything in that I know. So we're going to have the integral of sec squared x. The tan squared x is going to become u squared. And we're still integrating this with respect to x. Now if we have a look, what have we got left over with x's in? We've got a sec squared x and a dx. So what we can do is we can replace sec squared x dx with du. So that becomes u squared du. And now integrating that, we get a third u cubed. Now we can replace, we can say that's a third u was tan x, and then that's tan cubed x. So that's what we get when we integrate this part here. And now we can just integrate as normal. So we're going to have a third tan cubed x And then if we look at the other parts that we wanted to integrate, integrating the 1 will just give us plus x. And then integrating the negative sec squared x will just give us negative tan x. And we're doing that between the limits 0 and pi on 4. Putting those limits in, we're going to get a third tan cubed pi on 4 plus pi on 4 minus tan pi on 4. I'm putting that in brackets. Then minus a third tan cubed 0 plus 0 minus tan 0. Then we want the exact value. So putting that in our calculator for this part, we get a third, because tan of pi on 4 is tan 45, which is 1, cubed it gives us 1. So that's a third plus then pi on 4. Minus pi on 4 is then just minus 1. And tan of 0 is 0. So all of this bracket will cancel just to give us that. So a third minus 1 is then minus 2/3. And then we're just going to cross multiply to give us 3 pi minus 8 over 12 as our final answer.